Hi, and welcome to the video on balancing nuclear equations. So before we begin, I just want to break down what we mean by balancing nuclear equation. This is a nuclear equation. A nuclear equation shows you what happens during a nuclear reaction. You see there's an arrow in the middle, and on the left side of the arrow you have your reactants. Sometimes you can have, in this case, like 2 reactants, or in example number 3, you can have 1 reactant or more. But whatever's on the left side of the arrow are your reactants. On the right side, you have your products, and the products are what you make. So the reactants are what you start with. They're like your ingredients when you're cooking, and your products on the right side of the arrow are what you make. Now, just like in a math equation, which is sort of separated by an equal sign, in a nuclear reaction equation, or even in a chemical reaction equation, it's separated by a yield arrow, and it shows you the direction of the reaction. The other thing to note is what do we mean by balance. So a balanced reaction has the same amount of mass or matter or energy on both sides of the arrow. And the way that we keep track of that with a nuclear reaction is keeping track of the protons and neutrons. And specifically what we use, the total mass number and the total atomic number have to be the same on both sides. So in these problems, you'll notice that there is one blank, and you have to figure out what goes in the blank based on how you would balance it. So I'm going to go through these 2 examples that are already done for you. So this is what the answer would look like. But if you didn't have the answer, if there was just, let's say, a question mark here, how would you solve that? Okay, so let's tackle this right now. All right, we're going to start with number 1, but I first need you to make the correction on number 1. The atomic number of aluminum is 13, not 12, so we're going to go ahead and change that. Okay, so in order to determine if what must go in this blank to balance my reaction equation, I'm going to start on the side that's complete, that has no blanks, and I'm going to calculate my total mass number and total atomic number. So basically add the 2 top numbers together, 27 plus 4, that gives you 31, and then the 2 bottom numbers, which is your atomic number, 13 plus 2, it gives you 15. Okay, so I know my total mass number and I know my total atomic number on the reactant side. We're going to do the same thing on the product side, but sort of in a different way. So since there is a blank here, I know that the total mass number, when I add up the 30 and the mass number of my unknown, must equal 31. So I'm going to set that equal to 31. And I'm asking myself, 30 plus what will give me 31? And of course that will be a 1, so I'll put a 1 there. I'm going to do the same thing for the bottom. So remember, the total atomic number on the reactant, or left side of the arrow, is 15. That means the total atomic number here must be 15. And I'm going to ask myself, 15 plus what will give me 15? And of course that's a 0. All right, so now I have a little bit of information about my unknown. To finish it off, I need the symbol. Now if you look at this unknown, you'll notice something strange about it. In the bottom here, you have, where the atomic number is, you have a 0. Remember, the atomic number is the number of protons? So that should be your clue that this is not an element you would find in the periodic table. So what you want to do is you want to go ahead and take a look at the particles that are here, because there are some particles that are also included that we need to just sort of take a look at. And the particle that matches having a top number of 1 and a bottom number of 0 is here. It's the neutron. So I'm going to put a symbol of N. Okay? Great. Let's take a look at our second example. And our second example, we're going to do the same thing. So my first step is to start on the side that has that's complete, and again in this case it also happens to be on the left side, so on the reactant side, and I add up my top numbers and bottom numbers. So 633 plus 2 will give me 65, and then 29 plus 1 will give me 30. So on the product side, I know that my total must be 65 and 30. Okay. So now I need to figure out what's going to go here to give me 65 and 30. Now, before I press on, I want us to take a look at this here. You see there's a coefficient of 2 in front of this neutron. So what does that mean? That means we have 2 neutrons. So I'm going to have to distribute or multiply that 2 to the top and bottom number when I do my math. Or I can sort of write it out as this. This is equivalent to saying there's 2 neutrons here. All right, so let's try to figure out what my numbers are, and then I can figure out what my symbols are for my unknown. Okay, starting with the top. So the mass number, I already have a 2 here, all right? So 2 times 1, or 1 plus 1. I have a 2, so I'm asking myself 2 plus what will give me 65? And the answer to that is 63. Now on the bottom here, I have 2 times 0. Now 2 times 0 is just 0, or 0 plus 0 is 0. So I'm asking myself 0 plus what is 30? And if put that down, that's just 30, okay? So now this, I've got my numbers. The last thing I need to do is figure out what my symbol. So remember to identify your element. In this case, it's not one of these special particles here, because you can tell because the bottom numbers for these most of these special particles are sort of strange. To figure out what the symbol is for an element, you're going to look on the periodic table and find the one that has an atomic number of 30. And if you look on the periodic table, you find that that is zinc. So the symbol here is Zn. All right, so to quickly recap, for all of these problems, you want to make sure that the total mass number and atomic number are the same on both sides. When you do your calculations, you're going to start on the completed side, so the side without the blank, add up the total mass number and the total atomic number. Then on the side with the blank, you're going to figure out what number must go for your mass number and your atomic number for your unknown, so that you can have the same total as you have on the completed side. And then to figure out the symbol, if you have a number like 0 or -1, something strange, look at the particles here for the symbol. Or if you have a regular number from 1 to 118, you would look on the periodic table, use the atomic number to find the symbol. All right, I hope you found this video helpful, and if you have any questions, please don't hesitate to shoot me a Schoology message. Have a quality day.